Question 3 is asking us to find the derivative of a function that is written as a product. There is implied multiplication between the 6x to the 4th times the natural log of x. And if you didn't immediately see the product, ask yourself, where's the function sending the input? I see that input x going to two different parts of that function rule. In the first part, x is being sent to a variable base that has a constant exponent. So I know I'll need to use the power rule to take the derivative of 6x to the 4th. But in the second part, that input is being sent to the argument of a natural log. That means we'll need the log rule for exponents to find the derivative of ln of x. So that helps me also see that I have a product. So we need to figure out all the pieces required to fill in this product rule template. And there's no algebra or anything I could do to allow me to avoid the product rule. But the good news is, even if there was, the product rule will always work if a function is written as a product. So here we have a first term times a second term. So I'm going to find all these building blocks. My first term is 6x to the 4th. That's just straight up power rule. I drop my exponent down to the front. I multiply it with 6. That's 24. I rewrite the base exactly as I see it. It's a plain old x. I decrease that exponent by 1, so it becomes a 3. Then here comes the chain rule part. Since the input was sent to the base, I tack on the derivative of the base. But the derivative of a plain old x is just 1. So the derivative of the first part of the product, the first factor, is just 24x to the 3rd power. Okay, now my second factor is natural log of x. I'm going to use the generic log rule. So I'm going to think of this second term as log base e of x. Natural log is a special case of logarithms that has an understood base of e. And now if you have memorized the special case rule for logs, that's great. If not, you can always use the generic log rule, and that's what I'm going to do here. So my generic rule says I start by doing 1 over natural log of the base, and of course here my base is e, so I'm going to do 1 over natural log of e. Now that's what makes this a special case, right? Because the natural log of e is just 1, so I end up with 1 over 1, which is just 1. But anyway, so then the next part of the rule says I multiply by 1 over natural log of the argument. My argument was a plain old x, so I'm going to do 1 over, sorry, not natural log. Pardon me, y'all. It's just 1 over the argument only. Oh my goodness. So 1 over x. And then here comes the chain rule. The chain rule says you tack on the derivative of the argument. The argument is just a plain old x, so I'm going to tack on the derivative of a plain old x, which we know is just 1. So the derivative of the second factor is just 1 times 1 over x times 1 again. So the derivative of the second factor is just 1 over x. Now, if you have memorized already that the natural log of x has derivative 1 over x, that is amazing, and that's a really useful thing to memorize. But you don't need to memorize it. You can find it by using your generic log rule. But if you can memorize that, that would be awesome. Okay, so now we have all the pieces we need for our template. Okay, so here we go. My product rule template says we do the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So let's find all those pieces. Okay, so my first factor was just 6x to the 4th. And the derivative of the second factor turned out to be just 1 over x. Plus the second factor, that was natural log of x, times the derivative of the first factor turns out to be just a 24x cubed. Okay, now let's see if we can clean this up at all. I can. When I go to multiply the first times the derivative of the second, that's 6x to the 4th times 1 over x. I can make the 6x to the fourth a fraction by writing it over a 1. And then I can multiply across and do numerator times numerator and denominator times denominator. And when I do that, I'm just going to end up with a 6x to the fourth in the numerator and an x in the denominator. And those x's will divide out. There'll be 3 factors of x remaining, and they're all going to be in the numerator. So I can just rewrite that as 6x to the third plus, now there's nothing I can really do here when I multiply the second times the derivative of the first, but I can change the order of the multiplication. We typically write those natural logs at the end just to make it easier to read. So I have 24x cubed natural log of x. Okay, so that is my derivative. I can't combine those like terms. I have 2 terms here. I have this 6x cubed, and that's being added to this term, 24x cubed plus, 24x cubed times natural log of x. But I can factor out a GCF, and that's what we're asked to do up in the directions. So what is my greatest common factor between those 2 terms? Well, I see they both have an x cubed, so there'll be an x cubed in the GCF. And they're both have coefficients that are multiples of 6, so I can factor out a multiple of 6. So I can rewrite this function, this derivative function, right? This function is a derivative. I can factor out the 6 and the x cubed. And let's see what's remaining in those 2 terms. So what's left over in my first term? Well, if I factor out the 6 and I factor out the x cubed, what I'm really doing there is dividing that out. Undistributing, unmultiplying is dividing. So 6x cubed divided by 6x cubed would just be a 1. So there's going to be a 1 placeholder in that first term. And then for the second term, if I did 24x cubed natural log of x divided by 6x cubed, those x cubes would divide out to 1. And then 24 divided by 6 would be 4. So I'd be left with 4 natural log of x. So I'm factoring out a factor of 6 from 24. I'm changing that 24 to 6 times 4. And I'm factoring out the 6. But that left my 4. Then I'm factoring out all the x factors. X cubed is coming out. So that's gone. And then I'm still left with that natural log of x there. Okay, and so that's what's remaining in that second term. So that means our derivative in factored form is just going to be 6x cubed times 1 plus 4 natural log of x. There we go.